Welcome to the fourth lecture in the Fighting Disease series. Today we will examine why germ theory was such a significant turning point in the fight against disease. This lecture will be split into 4 parts. The first part will examine the beliefs about the causes of disease before germ theory. We will then examine the work of Louis Pasteur and the scientific process he used to arrive at germ theory. We will then examine the rivalry that Pasteur had with a German scientist called Robert Koch and how this accelerated society's understanding of bacteria. Finally, we will examine the long-term impact of germ theory by linking it to future developments in the fight against disease. By the 19th century, the theory of miasma was the most common belief about the cause for disease. This theory originated during Roman times and came from the idea that disease was caused by the foul air of swamps. The 19th century saw the Industrial Revolution sweep across Europe. This resulted in a deterioration in public health conditions. Foul smells were everywhere, from the putrid river water to the overflowing cesspits below shared privies, to the smoke from chimneys. Life expectancy in the cities was much shorter than in rural areas, and so people naturally attributed the deadly diseases of cholera and typhus to the foul air that hung to the city streets. The theory of miasma was so widely accepted that it became difficult to challenge it. This is called social conservatism, when people do not want to look beyond an accepted idea or theory. Respected scientists stuck with the theory of miasma, and this made it harder for others to seek out the true cause of disease. However, there was a key development in technology that pushed scientists closer to the true cause of disease. By the mid-19th century, scientists could use microscopes that were powerful enough to see germs and bacteria. This resulted in a new theory, called spontaneous generation. This is the belief that germs randomly or spontaneously generated out of decaying matter. This was very close to being the correct theory, but it put the cart before the horse. It is germs that cause decay, not the other way around. It was a French chemist called Louis Pasteur that finally arrived at the correct theory in 1861. He arrived at what is now known as germ theory. That it is germs that cause decay. From this he went on to prove that it was also germs that cause disease. Louis Pasteur was employed by a brewery to investigate why casks of beer were going stale. He arrived at a hypothesis that the casks were not airtight and so germs were entering. It was this that caused the beer to go stale. In order to test his hypothesis, Louis Pasteur used the swan neck flask experiment. The swan neck flask is so named because of the unique curve in the neck that traps particles and stops them from entering the flask. Pasteur placed the beer into the flask, then boiled it, so to kill any existing germs. He then left the flask open to the air. However, as the invisible particles of germs entered the flask, they became trapped in the neck, so they could not enter the flask. After several days, he studied the substance under a microscope and found that it remained germ-free. He then repeated the process with one variation. He broke the neck of the glass. This allowed germs to enter the substance. After several days, he studied it under a microscope and discovered that the substance was now contaminated with germs. A key part of this experiment was the boiling of the substance to kill any pre-existing germs. This proved to work. It is now used in various processes to make liquid sterile and is known as pasteurization. The most common form is milk. Here in Britain, all our milk is pasteurized before it is sold to us, so to kill off any bacteria or germs. Pasteur continued his investigation into airborne germs. He took samples from the air in both rural and urban areas. He discovered that in densely populated cities, there was a far greater density of germs, whereas in the countryside, there was a sparser number of germs in the air. This helped to explain people's belief in miasma. It wasn't the foul smell in the urban areas, but the invisible germs in the air that caused sickness. Pasteur released his germ theory in 1861. However, he faced significant opposition from the medical community. Many influential figures in Britain, including Florence Nightingale and the British government, rejected germ theory when it was first published. This is because he wasn't a doctor, he was a chemist. His original investigation had been on beer for a brewery, so medical experts had a hard time believing it could link to the cause of disease. Secondly, Pasteur did not have a fully developed understanding of what germs were. Over the next 15 years, he would develop his understanding of bacteria, but he would also face fierce competition from a German scientist called Robert Koch. Throughout the 1870s, there was a fierce rivalry between Louis Pasteur and Robert Koch. This is partly due to patriotism. The Germans defeated the French in the Franco-Prussian War of 1870, and a pseudo-war continued through the pursuit of new scientific breakthroughs. Both Pasteur and Koch worked on the development of new inoculations during the 1870s. Pasteur's main project involved chickens. He studied chicken cholera, a poultry version of the most deadly disease of the 19th century. His breakthrough came by chance in 1879, however. He went on holiday partway through an experiment, so told his assistant to inject the healthy chickens with the culture of bacteria that he had been developing. But his assistant forgot. The culture of bacteria was exposed to the open air for a month. When Pasteur returned, he injected the chickens with this old culture. The chickens remained healthy. This led to the discovery that a culture of bacteria will weaken in strength when exposed to the air for a prolonged period of time. It also helped to explain the link between cowpox and smallpox, since the cowpox culture was essentially a weaker strain of smallpox. Pasteur even named his new inoculation a vaccination in homage to Jenner. Robert Koch focused his work more on the study of bacteria. He wanted to identify the different strains of bacteria that caused each disease. To do this, he developed the agar gel, which was used to both study and grow bacteria. It was also a member of his team that invented the Petri dish, which is still used today. In 1876, he discovered the bacteria for anthrax. He did this by taking bacteria from anthrax-stricken chickens and injecting this into the bloodstream of healthy mice. The mice then caught anthrax. He used this experiment to prove that a specific bacteria could cause a specific disease. He would later go on to receive the Nobel Prize in Medicine in 1905 for his discovery of the bacteria for tuberculosis, which would result in a vaccine for this extremely deadly disease. However, during the 1870s, both Pasteur and Koch were working on the development of an anthrax vaccine. There were some benefits to this competition since the French and German governments invested money in their scientific research. However, if the two scientists had been able to collaborate, then they might have arrived at the vaccine sooner. Let's now look at some political cartoons from the late 19th century that show Pasteur and Koch in their fight against disease. This is a cartoon for a French magazine that shows Louis Pasteur, who is portrayed as an angelic figure, so to glorify his work. You can see that his weapon is a syringe used to inject people with a vaccination. It is aimed at an aggressive dog, who is frothing at the mouth. This is to show the dog has rabies, which could be passed on to humans. Pasteur was able to develop a vaccination for rabies. Let's now look at a cartoon of Robert Koch, who is depicted here like a chivalric knight on horseback. You can see that Koch's weapon is a microscope to denote his achievements in the study of bacteria. He is slaying a snake, a symbol of evil, that is labeled as tuberculosis. This is to celebrate Koch's development of the tuberculosis vaccine. By the end of the 19th century, most of the medical community accepted germ theory as the correct theory for the cause of disease. Therefore, society slowly began to reject the notion of miasma. This had a profound impact on surgeons and hospital staff. They now had to accept that patients could die from infection due to germs. A surgeon named Joseph Lister was one of the first British medics to accept germ theory and use it to develop an antiseptic called carbolic spray. Others, however, were slow to accept their new responsibility to keep their facilities clean and hygienic. Once they did, both operating theatres and hospital wards had more sanitary conditions. This reduced the number of deaths from infection. The development of new vaccines for anthrax, tuberculosis, cholera and rabies spurred future scientists to develop vaccines for other deadly diseases. The work of Robert Koch and his team in the study of bacteria made a tremendous impact on this. Arguably the most significant long-term development came in the treatment of disease. It was impossible for any scientist to arrive at a genuine scientific treatment for disease until they fully understood the cause. Once germ theory was fully accepted, scientists turned their focus to what they called a magic bullet. They now believed that it was possible to find a type of bacteria that had the magic properties to cure a disease. It was actually a former student of Robert Koch, called Paul Ehrlich, who formulated the first magic bullet in 1909, which provided a cure for syphilis. This would be the first stepping stone to the development of antibiotics. Let's now return to our overarching question of, why was germ theory a turning point in the fight against disease? If asked to discuss a turning point, it is important to show an understanding of the theories that existed before the breakthrough. Therefore, it is worth discussing the theories of miasma and spontaneous generation and how this stagnated progress in the fight against disease. It is also important to understand why Louis Pasteur was significant as an individual and how he used scientific processes to prove his germ theory to be the correct theory for the cause of disease. You could also be asked about Robert Koch and how he contributed to this important turning point. For Koch, focus in on his study of bacteria and how this led to new vaccines. Finally, in order to fully assess why germ theory was a turning point, it is important to consider the long-term impact. There are 3 ways you could approach this. You could discuss the use of germ theory in hospitals and operating theatres to minimize the spread of infection. You could discuss the later development of vaccines. Or you could discuss how germ theory led on to a new theory about magic bullets and then to the development of antibiotics. Thank you for listening. Tune into my next lecture where we will examine the development of antibiotics with a specific focus on penicillin.